Here's a video for Chapter 5, Environmental Systems and Ecosystem Ecology. So this case study on the vanishing oysters of Chesapeake Bay is actually really important. Basically what happened at Chesapeake Bay, which is located here in Maryland, all their oysters industry basically collapsed. This is due to over harvesting. We'd like to say it's overfishing, but they're not fish, so that's why it's called over harvesting. And we'll talk more about that in Chapter 16. Habitat destruction, again, we will talk about that in Chapter 11 and 12 more, and disease, which is Chapter 14. And also the biggest thing is the water pollution, which is high levels of nitrogen and phosphorus. And this is probably one of the big ones for this chapter, the most concerns. Now, where are we getting all these high levels of nitrogen and phosphorus? They are from agricultural fertilizers. The area that surrounds the Chesapeake Bay is a lot of farmland. And unfortunately, this is called a dead zone. And a lot of times these fertilizers are sprayed on crops, but it's not used up all the way. So then there's excess nitrogen and phosphorus that gets washed away with runoff and into the Chesapeake Bay. Animal manure. The way that we raise animals these days has changed from the past. They're much more concentrated in certain areas. So it's basically an overflow of animals on the manure, the poop, and eventually it washes away into the body of water. All right. Also stormwater runoff. Now, traditionally it's treated. However, when there's major storms, the runoff, it can contain some nitrogen and phosphorus from just people's households, just from the fertilizers that they use on their lawns, or golf courses, or even things like the car washing industry, because of all the detergents and cleaners that they use, a lot of times contains phosphorus. And all these things create a dead zone. All right. Now, the largest dead zone actually in the United States is in the Gulf of Mexico. And that's mostly because of, again, farming fertilizers. And what happens is the Mississippi River that covers multiple states drains into the Gulf of Mexico. So it picks up all the fertilizers from Arkansas, Missouri, Mississippi, and other states it runs through and brings them all to the Gulf of Mexico. So that's why they are the largest dead zone. Other words you need to know, make sure you know what a watershed is, and hypoxia. Okay. Feedback loops. Now, ironically, these are the opposite of what their name suggests. A negative feedback loop is actually good, and that's because it reverses a problem and enhances stability. Again, our goal is to reach homeostasis, where everyone is happy. So if you look at the picture here, it explains how a negative feedback looks. So basically, if it's too cold, your brain realizes that, and when you wear warm clothes, your body warms up. And now eventually you get to too hot, your brain works, seeks shade, or you sweat naturally, and your body cools, and then you go back down. So this is a negative feedback loop, and that's just because your body can actually regulate itself. So that is our goal. So just make sure you review this figure here. Okay. Now, if you look at this figure up here, it talks about your sunlight. So a solid ice surface versus glaciers, they cover it, yes? Sunlight's here, as you can see the light bounces off. It reflects off of white surface, this is the albedo. Now, as the climate warms, however, sunlight is absorbed where dark surfaces are exposed. So notice wherever there is dark, now the water, because it's melting, it's not reflecting off anymore. And then over time, the light absorption speeds warming, then all the ice caps melt, and little bit is being reflected. So this is an example of a positive feedback loop, and as if you couldn't figure out, it is bad, all right? And that is because it drives a problem further. So glacier melting is a major problem, and unfortunately, it's just getting worse because of this. All right, so glacier melting, erosion, cancer, human population, anything with exponential growth is considered a positive feedback loop. And that's just because we can't stop it. It happens so rapidly and quickly. All right. Now, a word that's not in your book is the Gaia hypothesis, and it basically says that the Earth is a self-regulating complex system that maintains homeostasis. All right, so make sure that you write that down somewhere because it will pop up on the AP exam. All right. Now, on this page, there's a couple of vocab words. Again, you need to know what runoff is, watershed, and airshed. And we've talked about these two already. All right. Now, if you look here, this is the Chesapeake Bay, and it talks about dissolved oxygen. All right, and just like what we talked about in our eco columns, fish need dissolved oxygen of at least 3 milligrams per liter or ppm on average to survive. The fish that we have actually in our eco column, that Gambusia, they can actually live with 2 ppm, so they're a little bit more hardier in that way. But unfortunately, when all these little rivers drain into the Chesapeake Bay, they're adding extra nutrients. And unfortunately, that's going to cause the dissolved oxygen in the bay to lessen. All right, so it's industry, forests, cities, farms, they all influence the Chesapeake Bay. So look at that. You can see the dissolved oxygen levels a little bit closer. Here's the bad area, obviously where what major cities are, so it's all due to the runoff going from the tributaries going into the different parts of the bay. Okay. So again, under 3, that's when all of your fish, your oysters, and things will end up dying. All right, eutrophication. You will see questions about this process. You need to understand how it's caused. And this is basically what causes dead zones, all right? And it's happening all over the world. So eutrophication, basically what happens is from farm fertilizers or animal manure or even urban sewage, you get extra nutrients, okay? And it's always gonna be nitrogen and phosphorus. These are the extra nutrients that are gonna enter a body of water. It's going to be washed away by rain with storm runoff, and eventually enter your rivers, lakes, or oceans. Now, we, luckily here in the United States, actually have the Clean Water Act that helps protect this and regulate this. However, a lot of other countries, your poorer countries, have no regulations at all. Especially the poorer countries, this is where urban sewage is a major problem. Every once in a while, we do have a leak. It happens a bunch, especially in the Jersey Shore. That's why if certain beaches are closed, it's due to a sewage leak. Okay, so anyways, you've got all these extra nutrients in these bodies of water. Guess what? These nutrients, plants love, they need them. So then that's what causes your algae blooms to occur. Now, they're not bad right away. The problem is the algae blooms block sunlight. So the plants that are actually supposed to grow at the bottom of the bodies of water can't get sunlight, so they die off, and then eventually these guys die off. Now, this is where it comes into bad. The decomposing bacteria or algae blooms, this is using up all the dissolved oxygen. All right, so it's the decomposing part of the algae is what causes us to lose the dissolved oxygen in our body of waters that we need. And then eventually it causes hypoxia or a dead zone, and all of your aquatic life eventually dies. Okay. Now this image here actually is pretty good at explaining all the processes. So definitely look at this figure and the captions as it explains the steps of eutrophication. Can't flip the page. Okay. All right. Next thing, just quick vocabulary. You need to make sure that you know the difference between lithosphere, atmosphere, hydrosphere, biosphere, and the ecosystem. Lithosphere, it's also sometimes known as the geosphere. Okay, we talked about that on page 32 a little while back. That's basically all the sediment and rock of the Earth's upper part. Okay, atmosphere is all the gases that surround the Earth. Hydrosphere is all water, so fresh, salt, solid, liquids, gases, everything. Okay, biosphere, pretty self-explanatory. It's all the Earth's organisms and all the non-living or abiotic parts that they interact with. So make sure you know all these. Okay. All right. Now, okay, gross primary productivity or production. Okay. This is basically energy made by autotrophs in an ecosystem. So just remember from the previous chapter, 90% of all energy that your producers make is lost as heat into the ecosystem. 10% of it is what's actually used in your plant tissues or is available for consumers to eat. So that you, again, need to make sure that you know these numbers. Okay. Productivity, it's basically the rate at which energy is converted to biomass. Okay, this is all the living energy. So your net primary productivity is the energy available to the consumer, so 10% on average. So these are related, okay? Your net primary productivity, it increases on land with temperature and precipitation. So tropical rainforest is the one that has the highest net primary productivity. The ocean with light and nutrients, they get all the ocean nutrients from uplifting from the surface. Now this chart here is pretty important. There are a lot of time questions where they say blank is an example of an ecosystem or a biome that will have the highest or the lowest net primary productivity. So make sure that you know examples and the highest and the lowest. As you can see here, your algae beds and the coral reefs is number 1, followed by tropical rainforests. Okay, so your terrestrial and your aquatic, your land or your water one. And if you go down here, an open ocean is actually pretty poor. Okay, there's nothing there. And then your deserts and your semi-desert shrubs. So make sure you do know this figure.